Section 2.2, Functions and Graphs. Determining whether a relation represents a function. So a function is a special type of relationship between your x's and y's. Let's begin with that definition. A relation of a set ordered pairs. The set of the first components of each ordered pair is called the domain, and the set of the second components of an ordered pair is called the range. So recall your ordered pair is always x comma y. In an ordered pair x comma y, the x is the domain and y is the range. So a function is a special mapping or relationship between your x's and y's. So let me try to explain it using this analogy. So let's say these circles are all of your x's that you can have and all of your y's. A relationship that I think helps keep track of this is people and birthdays. So say person A has a birthday, their birthday is the 1st of January. Person B has a birthday, their birthday is the 2nd of January. And person C has a birthday, and cool, it has the same birthday as person B, the 2nd of January. It would not make sense. Well, first of all of these make sense. One person, like person A, they have a birthday, and it is possible for two different people to have the exact same single birthday. It does not make sense for a person to say that they have two birthdays. So person A can say, oh yeah, my birthday is also the 2nd. To try to fit in, I guess you can say. That doesn't work. That is not a function. So if we represent these as points, we have A and 1 as x's and y's. We have B and 2, and we have C and 2, but we cannot have A and 2. That doesn't make sense. So if we take a bit closer look at this, we can see that your y's can repeat, but your x's can't repeat. That would make it so that you do not have a function. So in your function, your y's can repeat only. And this analogy of birthdays and people is always a way that I try to think to keep track of this. Because I know if you just think of the mappings, it's kind of different. Definition functions. A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. The input values make up the domain, and the output values, your answer, make up the range. Using function notation. The notation y equals f of x defines a function named f, because we see an f right there. This is read as y is a function of f of x. The letter x represents the input value, or independent variable, and the letter y of f of x represents the output value, or the dependent variable. All right, let's do an example. Evaluate f of x is equal to x squared plus 3x plus 4 when a, f is equal to f of 2, b, f of a, and f of a plus h. Okay, so what this is giving, it's giving us our equation. And we're used to seeing them as y equals. Now we have f of x equals. We're using function notation. Function notation is cool because it saves us time. So we can read this as let x equal 2. And we're saving ourselves all that effort and time of writing that sentence of saying, if x squared plus 3x minus 4, let x equal 2, right? That is what this f of 2 is saying. Okay, so let's go ahead and plug in 2 for every x. So we have x squared plus 3x minus 4. And for every x, I'm going to substitute a 2. So just take a moment to highlight what we're going to do so that we have x squared, or 2 squared, plus 3 times 2 minus 4. From there, we just follow order operations. So we first have to square. So 2 squared is 4, plus 6 minus 4. 4 plus 6 is 10, and 10 minus 4, we get 6. The way we write our answer is f of 2 is equal to 6. That is our answer. Okay, let's take a look at B. B is saying for every x, plug in an a. Okay, so let's go ahead and write our equation. We have x squared plus 3x minus 4. And I just do that so I can highlight and show you that every time we see an x, we're going to replace it with a. That's what it's asking us to do. So let's go ahead and do that. We have x squared, or a squared, plus 3 times a minus 4. Okay, a squared, a times a is just a squared, plus 3 times a is just 3a minus 4. Okay, so a squared plus 3a plus 4. There's something else I can't do. I can combine any like terms. So that is our answer. So f of a is equal to a squared plus 3a minus 4. On to example C. So same idea, even though it looks a bit more complex, all we're doing is we're replacing x with a plus h, that entire quantity. So that we have x squared plus 3 times x minus 4. But instead of x, we're going to write a plus h. Okay, to begin, we have to go ahead and multiply this out. A plus h squared is a plus h times a plus h. Okay, we have to go through the process of multiplying it out. So let's go ahead and FOIL. A times a is a squared. A times h is ah. H times a is ah. And h times h is h squared. Okay, let's combine like terms. We have a squared, and then we have two ah's, so that's 2ah plus h squared. Okay, so far we have a squared plus 2ah plus h squared. And we still have to multiply that out. 3 times ah minus 4. Okay, let's multiply that out. 3 times a and 3 times h. So that we have 3a plus 3h. Let's bring down the minus 4 and write down what we have in the beginning. A squared plus 2ah plus h squared. Okay, are there any like terms that we can add? Yeah, I can add that 3 minus 4. So that we have a squared plus 2ah plus h squared plus 3a minus 1. And that is our answer. I can't combine any more like terms. That is it. All right. Now we have a part D. Now these last two parts, part C and part D, they're really challenging. I would say this is more of a college algebra question. But I think that even though we are in intermediate algebra, we can still do it. Okay, so we kind of have bits and pieces of this done. So we have a plus h done, and we have f of a. So let's go ahead and plug those in. We have pieces of this done. F of a, what is that equal to? Right? And we also have f of a plus h, which is all of this. So let's go ahead and write those down. F of a plus h, that is f of a plus h, is a squared plus 2ah plus h squared plus 3a minus 1. Minus, and then we're going to subtract f of a. Well, we already have f of a. F of a is a squared plus 3a minus 4. All of that will be divided by h. Okay, you'll see this again when you continue on to your college algebra course. This is a very important formula. This is called the difference quotient. And you'll actually see this again in calculus. So it's nice that we're seeing it now. All right, so as we're looking at this, as we look into our numerator, are there any like numbers that we can go ahead and combine? And there is, right? I can go ahead and see that I can, well, first of all, I have to go ahead and distribute that negative so that we have a squared plus 2ah plus h squared plus 3a minus 1 minus a squared minus 3a plus 4. Okay, now I see that I have an a squared minus a squared, so that's 0. We have a 3a minus 3a, that's 0. And that's it. So our answer would be 2ah plus h squared. And then I can add these, negative 1 plus 4 plus 3, all over h. And that's the simplest I can write it. Now, the questions we'll see a lot more of are the ones we're just evaluating for a function, for a number. So this first example, or this next example, find the indicated function value. So this is telling us to plug in a 5 into our function 3x plus 2. All right. F of 5 is equal to 3x plus 2. Let's plug in a 5 for x. All right, let's clean it up. 3 times 5 is 15, and plus 2 we get 17. So our answer is f of 5 is equal to 17. Next one. G of 2 is equal to g of 7. G of x is equal to 7. All right, for this one, there isn't much for us to do. It's just telling us the answer of each outcome. So it's saying our answer is always 7. So g of 2 is equal to 7. There is nothing for us to plug it into. This is also called a constant function because we're always going to get that same answer. There's no x or value to plug in and work with. Next one. F of a plus 1 for f of x is equal to 3x plus 8. Whenever we have a question, an odd question, they may seem odd at first, where you have not a number, but an expression to plug in. Just think, okay, I'm plugging that in for every x. And highlight your x's, because sometimes we might have more than one x. So this would be 3 times, Instead of x, I'm writing a plus 1 minus 8. Okay, now I see what we have to do. Now we can distribute that 3 and clean it up. So 3 times a is just 3a. 3 times 1 is 3 minus 8. So we have 3a, and 3 minus 8 gives us a minus 5. So that is our answer. Graphs of functions. To graph a function, we find ordered pairs, x and y, or, now that we're using function notation, x and f of x. Plot them and connect the points. Note that y is f of x are used interchangeably, that is, y equals f of x. We are working with function notation in their graphs. Okay, so you might recognize this first one. This one's going to be a linear function. Okay, so I didn't include a chart. So let's go ahead and draw our own Cartesian plane. Okay, so let's pick some points for x. We only need 2, so let's pick maybe 0 and 1. Okay, if we let x be 0, we have 0 plus 2, we get 2. So I have the point 0, comma 2. If we plug in a 1, we're left with 1 plus 2, we get 3. 1, comma 3. So we have 0, 2, and 1 up 3. We know this is a line, so I know I just need to have a couple of points to see what my line looks like. Now, since we're writing function notation, you can think of it as x comma fx. Or you can use x comma y. If you see the other notation, you know it just means x comma y. Okay, next graph we haven't graphed one together before. This is called a parabola. It's a U-shaped figure. All right, let me guide you through this one. Now for this one, we have to be careful with our x values. So let me guide you. Let x equal 2, 0, and negative 2. Okay, so we want some space for our work. We want our output, and our goal is to create some x comma y, a point. Okay, so this is saying we're going to plug in. The first one we chose a 2, and I chose a 2 for you. So we plug in a 2, we're left with 4 minus 2 squared. All right, 4 minus 2 times 2 is 4. So we're left with 0. Have the point 2 comma 0. Next, if I plug in 0, I have 4 minus 0 squared. 4 minus 0 is just 4. So I have 0 comma 4. And then if I plug in a negative 2, I have 4 minus negative 2 squared. So I have 4 minus negative 2 squared is positive 4. You get 0. Negative 2 comma 0. Let's go ahead and plot these. So let's draw a Cartesian plane. I think 5 tick marks on each side should be enough. Okay, let's plot these points. We have 2 comma 0, 0 up 4, and negative 2 comma 0. Okay, this is our graph. It's a U-shaped figure and it's opening down. Next example. This one is called an absolute value function. We haven't graphed one together, so let me help you out. Let's draw a chart, and let's pick the points -2, 0, and 2. I chose those for you carefully. Okay, let's give ourselves space to show our work and show our answer, and then finally show our point. Okay, let's work this out. So we're saying we're going to plug in x and take the absolute value. So if I take the absolute value of -2, my answer is 2. If I plug in a 0, the absolute value of 0 gives us 0. If I plug in a 2, the absolute value of 2 is 2. So 2 comma 2. I think 4 tick marks on each side should be enough. Okay, so I have -2 comma 2, -2 up 2, we have 0, 0, and 2 up 2. Now we haven't studied these graphs in detail, so we will soon enough. This absolute value function creates a V shape. These are the points that help us create our V shape. Now, don't be alarmed by our last two examples. We'll talk about them more in future chapters. But whenever you're unsure of how to graph something, you can always do a chart. All right. A special type of function is a one-to-one function, in which each output corresponds to exactly one input value. So one-to-one function is a special type of function. And we'll talk about this a lot more later. So basically for the special one-to-one function, your x's and y's do not repeat at all. Okay. Next, let's talk about the vertical line test. The vertical line test can be used to determine whether a graph represents a function. What is a function? Well, we talked about that at the very beginning, right? A function is a representation of x's and y's, where your y's can repeat and your x's can't. That's a function. Okay, well, we can test if a graph is a function without having to look at their input and output values so closely. We can draw a vertical line that intersects a graph more than once. Then the graph does not define a function because a function only has one output value for each input value. So for this first one, this one is a function because it only crosses the vertical line once. The second one is not a function because it crosses our vertical line twice. Same thing for that third image. It crosses twice, so it's not a function. So again, the vertical line test helps us determine if a graph is a function. All right, that's it for this section. Thank you.